Hey everybody, it's Bill with the Edge of Eternity. Hope you're all doing well. I wanted to share with you a little bit of the new technology that's used in assembling today's cars. This picture you see is called a clinch joint, and you can see how the two sheets of material are mechanically joined. There is an interlock and a neck thickness that is used to clamp the two pieces together. That is an airtight and watertight joint. In this picture you see the control dimension the two arrows are pointing at. We call that control X, and we know that if that dimension is correct, the joint will have the proper configuration as far as the interlock and the neck thickness goes. Here's a picture of something that we call the twin joint. Now the twin joint can be two smaller sized joints that are useful on maybe a flange where the customer would like to have a shorter flange on a window opening or a door opening where they're trying to save material and have more visibility for the occupants. Here's a picture of what a clinch joint looks like in an assembly. It has a little button of a head, and then on the other side there's a little depression. You may remember from a while ago when I was doing this project, I was building this pedestal unit for a piece of technology that we use for clinching. And here's a picture of what that equipment looks like. I do have a video you can go back and check out of building that pedestal and that black bracket you see on there. But this is the type of equipment that is being used by the automakers today. It's all computer controlled. It has a lot of monitoring, and it's a very high quality, repeatable, and affordable process. Now, that was clinching, but this picture is going to show you another technology that's very similar in the way that it's performed, but it's a little bit stronger than the clinch joint. Actually, it can be very strong. And you see it coming up here. It's called an SPR, or a self-piercing rivet. This is also used very widely in the automotive body and white assembly processes. Here comes a couple of more images that will show you basically how this works. You see the rivet going through the top sheet and into the bottom sheet. And one thing you may notice here is that image is aluminum to steel. That is something you cannot spot weld. So these joining processes not only allow you to have a greener process, faster process, less maintenance, but it allows you to join dissimilar materials. You'll see in this next picture, you've got a steel rivet, an aluminum top layer of material, and then cast aluminum for the bottom layer. This is something that was not possible just a few years ago, but now with these new technologies of being able to mechanically join them instead of using heat and electrodes and the welding of dissimilar metals, it just wasn't possible. So this is the technologies that are being used today. Quality control. In the bottom part of the picture right now, you see where it says 0 millimeters. One of the quality controls for this process is making sure the head height is flush with the top layer of material. And then the part of the joint you can't see, which is buried inside of the material, you have to be sure that the legs of this rivet are flaring out properly, giving you enough interlock between both sheets of material and not cracking or fracturing the rivet itself. Here's an image that kind of shows you a section cut and what the part looks like if you were to make a section cut like that. Now, here is some of the automation running in a test cell, installing rivets. Now, if this was installing clinches, it would basically look exactly the same. The difference is with the SPR, self-pierce rivet, you have to load rivets. Right now it's going to a loading station or a docking station. It just dumped 60 rivets into the riveting gun, and now it's going back to the material where we're installing these rivets. Here you see the test samples that we were just installing the rivets in. Here's a look at the self-pierce rivet gun. The clinching gun would look very similar to this, but without the feeding apparatus to get the rivet to it. When you do a standard clinch, you're not adding any material or any type of a fastener whatsoever. Here's another look at the equipment through the fence, and some more here. Here we are installing more rivets. Now what we're doing here is we're doing several 100,000 rivets as a buy-off process for our customer. We can do about 1,140 rivets per hour. Depending on the rivet size and the reach of the gun and all of that, we can get up to 1,500 rivets an hour. These are used in very high production assemblies, such as the Ford F-150, which I have a couple of pictures of that coming up right here. This is the Ford F-150 aluminum body. There is not a single weld in this entire assembly. It was the first of a kind and a real success. So I just wanted to share a little bit with you about the new technologies that are being used to assemble the new vehicles that you're seeing on the road today. You may run into these in the future. I know a lot of you do a lot of work on cars, and this might be good information to know. We've all dealt with spot welding pretty much our entire careers. Things are changing fast. Thanks, everybody. Have a great week.